Hello everyone and welcome to the first lesson in intermediate Java programming. And this lesson is going to be what's called a late introduction to object-oriented programming. So in my courses, typically when you're taught programming, you're taught what's called procedural programming, which is that you have your main method and all of the code that you do comes from that main method and is pretty much self-contained. You might create a few helper methods and that's it. But Java is actually what's called an object-oriented programming language, and that actually has some significance. It's a certain type of programming, a style of programming. You have procedural programming, which is what you've learned up to this point. You have object-oriented programming, and there's also another type of programming called functional programming, which is usually reserved for the university level. So our learning goals over this entire unit, and this will probably be a series of 4 or 5 videos, is going to be to cover all of the basic elements of object-oriented programming. It's not going to take you up to an expert level, but it's going to allow you to actually understand and use and create programs with this object-oriented style. So before we get into the nuts and bolts of object-oriented, you have to kind of understand what you've done so far. And we're going to start with this idea of data types. Data types was like lesson 1, lesson 2 when you learn how to program. And that's because all programming at some point fundamentally comes down to data. You're reading in data, you're manipulating data, you're outputting data. It all has to do with data that you're working with. And in Java, a lot of what you learned and what you started with are called primary data types. So think of everything you might have used. Integers, characters, bytes, all that type of stuff all flows in together in what's called, in Java, is what's called primitive, which means it's represented sort of directly in memory. An integer takes 4 bytes, reserves it in memory, and you've got it there for your use. You've also used a few things that I've called complex data types. And in actual fact, what I was referring to was classes. And that's sort of what we're going to be learning today, is what this thing called a class was. And these types of complex data types, they had values, and those could have been simple values or they could have been more complex values. And they had a series of operations that could be done on those values. The easiest example would be string. So string was a complex data type. It was a class. And it had a set of values, which was all of the individual characters in that string. And then it had a whole bunch of behaviors or methods that were defined that you could do with that string, with that data. You could turn it to uppercase, you could turn it to lowercase, you could grab a particular character, you could grab a substring. Those were all specific examples of behavior that could be done with that complex data type. So here are some other examples from Java. So an int would be a primitive or simple data type. It had a value, which was 4 bytes, and you could assign it that value. And it had very simple operations, like plus, minus, comparisons, things like that. That was primitive, and there were special operations defined for it. These next 3 over here, these are classes or complex data types. One was a string, one is a color, and one is a robot. You might not have used all of these, but all of them will have certain values. String has a collection of characters. A robot might have a position, it might have a name, it might have other properties, a color, it might have how old it is. So those would all be values or properties. Color is an actual Java class which represents color using 3 numbers, 3 variables, red, green, and blue. Each of these things have operations. Now these operations are things that programmers have created and added to it. Why does string have the 2 uppercase method? Because someone thought, hey, it would be a great idea to add a 2 uppercase method, and so they went ahead and they created it. So every time you're like, oh, I wish I could have had this method with a string. Well, you could have, it's just the programmer didn't do it. And now that you're learning how to create your own data types, your own classes, you're going to be learning how to enhance it. You don't like the way string was written, you want more methods, create your own string class that can then add in features that you want to it. And that's totally legit and something that you're able to do. So the key here to object-oriented programming is that you've got these primitive data types. Fantastic. You also have these data types, classes that other people have created for you. Oracle created stuff when they had Java. Apache has added stuff. Google has added stuff. IBM has created stuff. All of these companies and people have created extra data types that you're able to import. Right? Whenever you import something into your program, you're grabbing something that someone else has written, some extra data types, and adding it to your program. And then the last piece, which is what's really important in this unit, is that you can also create your own classes, and you create programs that can use multiple classes together and do stuff with them. And that's where we're trying to get you in this unit, is to be able to create your own classes and do stuff with them. In Java, everything, almost everything, belongs to some sort of a class. We have a math class, we have a string class. Every program that you've ever written in Java belonged to a class. And that's why it's so fundamental to understand that. So, yeah, this is just an example. I kind of gave this already. If we want to bring in color to a project, well, we find a color that someone else has written, we import it into our code, and that's what this line here is. It's saying, okay, I want to use the color that's included in this library. And then once you bring that in, you're able to then manipulate it. You can create a color, in this case creating white. You could change the color, and any sort of behavior, any methods that somebody wrote for this class color, you're able to use and utilize. So the last little piece, kind of technical information, which is two definitions. You have what's called a class, and then you have what's called an object. And it's really important that you don't get these two terms confused. A class is referring to the blueprint. When you create a class, you're saying, this is the data, this is the type of data I want it to hold, and these are the types of behaviors that I want it to have. So you're defining that. When you actually go to create an instance of that, or an object from that, what you're doing is actually giving it values. So somebody created the color class and they said, yeah, I want it to have a long for red, and another long for green, and another long for blue, and that's the important information. But they didn't actually define what numbers, what values it would have. They just said it's going to have those three numbers. When you want to create a color, create an object, you have to give it information about what those colors are, so that the methods and the behavior can actually act upon those values. Here's a really kind of quick example. If I wanted to create a class to describe a blueprint for a Lego house, there's tons of ways that I could do that. I'd have to think of what are the important properties, what are the different types of houses that I might want to create. So in this case, I might think, well, I might want houses that are taller or shorter. So I might want to have a number representing the number of stories. Then I probably want to have different color roofs. Okay, so I could create a color and I have a property for that. Then I can go ahead and say, well, I want to know how many layers are in my roof. I want to know how many stories there are, but then I also want to know how many layers there are in my roof. So I might have another number for that. That's defining the blueprint. From that, I could go get my kids to create lots of different Lego houses with red roofs, with blue roofs that are really, really tall, 20 stories tall or 4 stories tall. And each of those Lego houses would be objects or instances of that blueprint. They could all follow the blueprint, but they would all be different. They would all be unique, and they would all have their own specific properties to them. And that's the difference that we're talking about. String was just an idea, a class that someone created with a bunch of behavior. But until you actually create a new string with values inside it, you can't necessarily manipulate that information. And you can create lots of strings and you create lots of colors and you can create lots of Lego houses, but they're all based on that blueprint. And if I don't have information in this blueprint for a Lego house, I cannot create something different. If I wanted to create a Lego house with 3 windows in here, I couldn't do that based off of this blueprint, because this blueprint only creates a house based on the properties that are contained in there. Hopefully that makes a little bit of sense. So you're going to have to create your own classes. And in order to do that, there's a number of steps. And some of these steps you're not ready to do yet. So for example, step 0, you don't yet know what an interface is. But you're going to be able to follow these steps all throughout your programming career to create your own data type or your own classes. And so you may create what's called an interface for it. Then you're going to create your class structure. So what are the key variables that belong to my class? What are the methods or behaviors? Then you can go ahead and fill in all the implementation details. So if I have a particular method that's going to add 2 things together, I have to fill in that implementation detail. Once you have that done, then you can go ahead and create as many instances or objects of that as you like. And here you can see a really simple example. This over here, my class, that's referring to the class or the blueprint that I've created. This name is going to be the variable to refer to the object, the specific instance of my class that I'm creating. And then this on the right that you've used in the past, what that's doing is it's going to actually create a new instance from that blueprint. So take the blueprint and now actually create space for all of the variables that are defined there. Maybe fill in some of the data for those variables, and then you have an object. It's called name, and you can refer to name to use all of the behaviors, or to change the variables, or to do things like that. Okay, so here's just a simple example of those steps in action. So number 1, you create the class. Public class person. I've decided, oops, that's not good. Public class person. Then you're going to add in your properties. So what are the key variables that you're going to have? You're going to have a hair color, maybe an age, and a birthday. There's nothing else, no other properties in this person. If you wanted more properties, you would have to add more data types in there. And then here I've decided what sorts of behaviors or key actions. And these are all methods. And I'm just defining them. I haven't given them any details yet, but I'm just defining them here. The mistake, by the way, that I made is you don't, as you know, because you've done these, you don't have these brackets over there. So then you go through and add in some implementation details into that. And so some of the implementation details are, how do these methods actually work? And this is where you must write the code. And this code here is going to run on these variables when they have values. They don't have values yet. And so I've plugged in some very simple behaviors into these particular methods. And then the last step, once you've done that, you've defined your data types, the information you're going to have. You've defined the behaviors, and you've given those behaviors implementation. Then the third step is where you can actually now start to create people, as many as you want, an array of people if you really want to. And each person is going to have this new qualifier. It's going to have its own variable, and it's going to have its own set of those variables, its own implementation of those variables. And so P is now going to have an age of 30, and then Q is now going to have an age of 40. And they're unique objects because they're just like the Lego houses. They're unique houses that I can show you, that are distinct, that have their own area of memory. And then you can start to manipulate them as long as you have methods that you can do stuff with. So I could change the hair property of it and give it a color. I could also use the older than method that I created to be able to do some comparisons and simple things like that. So it's really easy for students who are new to object-oriented programming to really get confused. It really is a different way of thinking of it, because all along I've been saying, oh, don't worry about public, don't worry about static, don't worry about putting methods, putting variables inside the class. I've said everything that's important happens inside main. Well, now we're starting to break that rule. You're creating variables inside your class, and you're creating methods that are no longer static. And we'll talk a little bit about what I mean by that a little later. So what I want you to try now is just practice. Honestly, take some time and practice. Create a class. See if you can add some variables inside that class. And then try to add some methods. You don't necessarily have to add the implementation details. You might not know exactly what these implementation details would do. But just add in some methods that are blank for now if you want. And then in your main method, create a robot. Create 2 robots. Create 3. Give them a name. See if you can understand how to manipulate and do that. And don't be afraid to ask me questions and comments, or send me an email, or use Google Hangouts. So that's kind of our first introduction. The next video is going to get into a little more details, right? We have to start breaking some of those rules that I gave you of everything is static. Well, you're going to learn that that's not the case anymore, right? Everything is public. Well, no. So we're going to break a few of those rules as we go through that. Okay? Thanks for listening, and this is the Java Meister saying Java out.